is 0, 0. Point B will be 3, 4. 3, 4. Okay, this should be the B. 3, 4. C will be 4, 3. And I'll draw again here. Almost same shape I brought it. Okay, let's do one thing. These lines are what the concept. What is the basic idea? The distance between any 2 points on the rigid body must remain constant during the motion. Now, what is the velocity of this point A is having VAX. Velocity of point A is VAX. Then what are other information given? VBX and VCY is given like this. Where is the center of mass? We don't know. It's asking also angular velocity. With this, what we can do here. So let me do one thing. Let me assume velocity of point A like this, VAY. I assume things, I'll put red mark. The assume things, I'll put red mark. VAY, VBY, VCX. So what should be the distance between any 2 points? Should remain same. So therefore, component of velocity of A along line AB should be equal to component of velocities of B along line AB. But we don't know that angles. I think we can get that angles. So the red color line, it is here. So we have VAX, VAY, VBX, VBY. And what is this? This distance is how much? 3, 4, no? So this will be 4 meter and this will be 3 meter. Now with this, can we calculate the theta 1? Yes, we know theta 1. Then velocity of the points along the line joining AB must be equal. So I'll get into the mathematics here now. VAX cos theta 1 plus VAY sin theta 1 must be equal to VBX cos theta 1, VBY sin theta 1. What are unknown things are there? VAY and VBY are unknown things. So what we know, VX and VBX. It's one equation, we'll get it. Now what to do after this? Similarly, what pen I'll go for AC. Similarly, I'll go for the line AC. Similarly, I'll go for the line BC. So how many unknowns are there? VB, VBY, VCX, and VAY. 3 unknowns are there. 3 equations, I'll write it. Then I'll solve it, I'll get the required answer. So after this, what we should do? We should do for now the AC, the line AC. So the line AC will be, there's a property of rigid body. Just we are taking up the property of rigid body to get that unknown thing. And now one more question, sir. How do you can say that components, I'll solve it if I get VAY negative, I'll change direction. So no need to get scared. And this distance is AC, so call this is theta 2 or anything, whatever the symbol, theta 2. Theta 2 also we can define it. Now write the equations now. VA x cos theta 2 plus VAY sin theta 2. Component of velocities along line joining that should be equal. Should be equal to VCX cos theta 2. This will be theta 2. So minus VCY y negative, VCY, it will be towards C, those velocities along AC positive, those which are towards that should be negative. Can you hear me?
Yes, sir.
Yes, sir.
Okay, no, complete pitch dark. I'm unable, other than mobile laptop, I'm unable to see anything in my room. No. Is it okay? Fine. This is similarly after this, what you should do for BC, you should do. I'll write that and you have to solve it. For the line, BC will do it. So BC will be, since they're given coordinates node, so it's quite easy. We can define that angle. So this is the BC. So there's a line BC, VBX. So define this theta 3. Again, write the same equations, the set of equations here. This should be the VBX cos theta 3 minus theta 3 will come. So how much component of that will be? VBY sin theta. VBY sin theta 3 should be equal to VCX cos theta 3 plus VCY sin theta 3. Solving this equation, so there's equation 2, there's equation 3. Unknowns are what? Theta 1, theta 2, we can find out from the geometry. Please do, he has given coordinates. Huh? No need to calculate theta 2, cos theta 2, sin theta you calculate. So it will come 3 by 5 or 4 by 5 like that. Substitute here to get the required answer. Okay, fine. This is about the velocities what I got. After that is asking angular velocity. What to do for angular velocity? How to bring? If you know velocity of any 2 points on rigid body, can you predict angular velocity? Go back to circular motion. Go back to circular motion. So now I know VAY, VAX, VB, VBX and VBY. With that, so shall I go for components of velocity perpendicular to line AB, omega relative. So the angular velocity, I think I'll write it here. Omega should be equal to angular velocity. So here, what is the method I'm using is, if there's a line, so somewhere I'll end up velocity of B like this. I don't know. I'm not very sure. And the velocity of A is like this. So if I get like this, so what shall I do now? And there's a length L. Then what is the angular velocity? How you define? Go back some VA cos beta